Yes, so the next chapter that we are starting, insolation कर लेते हैं पहले, right? Or latitude, longitude. The smaller one, huh? Insolation, yes. All the geography is interesting. Okay. Ah, every part of geography is very interesting. Okay. Next is now see here. The next chapter we are starting with insolation. It is important for your prelims. Which stands for incoming solar radiation. You may be aware of this. Incoming solar radiation. There was one man who gave this law, that is Wayne. Wayne gave law that if there is any high temperature body, okay, that will radiate its energy in the form of mostly in the short waves, right? So what is this? According to this Wayne's law, that is Wayne's law says if the temperature is high, okay, temperature if it is high, inversely proportional would be the waves, short wave or the long waves, right? Radiated waves. Waves, that is wavelength rather, of radiation. So the two things that you have to remember, if any source of energy is the primary source of energy, and if it is having very high temperature, it will release which type of waves? Short waves, right? So this is the relation. And therefore, solar radiation is in which form? It is in short waves. Short waves. Now, if I show you the radiation in form, see here, this is the Earth. And here, if we talk about, this is the atmosphere. Now, atmosphere will act as a transparent glass window for which radiation? For this short wave radiation. This is the short wave radiation, insolation. So more or less, insolation will be allowed to pass by the atmosphere. Atmosphere will rather act as an glass window for what? For the solar insolation. It is allowing for solar radiation. Whereas what happens to, say here, now the Earth surface, this is the primary object, very high temperature, short wave radiation. This is secondary source of energy, comparatively less energy. Therefore, which kind of waves would be there? It is long waves. So what will happen? You will see rather here the long waves. The long waves. Now this long waves will be absorbed here by the atmospheric gases like CO2, water vapor, and it will be reflected back. Yes, na? This is known as counter radiation. This one. Counter radiation. And the radiation which has been emanated from here in the form of long waves. So this is known as long wave, or the other names are terrestrial, ground, infrared, all are the names. Terrestrial, ground, infrared radiation, all are the names. Okay. Yes. Now please remember for your prelims, the band of the solar spectrum or the electromagnetic radiation. So this insolation comes in the form of electromagnetic radiations, and which includes the four bands. Now what these four bands are there? See here. Number one, it is going to be the shortest wavelength. Shortest wavelength. Second, it would be the visible light. Visible light. Third, it would be infrared infrared spectrum, and the fourth would be micro and radio waves. These are going to be the four spectrums in which the solar radiation will come. Okay. If I make the diagram of this one, so you will remember this diagram. Why you will remember, you will come to know. This is the first spectrum, nothing but shortest wavelength. Okay, this is the shortest wavelength spectrum. And what is the relation between wavelength and frequency? Inverse. If it is the shortest, then frequency will be high, highest frequency. Okay, and then we have visible light. This is the visible light. See here now, if I remove this bands here, this is visible light. You may be aware about this VIBGYOR. Then we have infrared. Then we have micro. And then finally we have radio waves. If I show you there, let's say the wavelength, here it is somewhat around 0.4 micron. Micron means 10 ki power minus 6. Okay, 10 micron means 10 power minus 6 meter. This would be somewhat around 0.7 micron. Okay, so this visible light is in between 0.4 to 0.7 micron. This will give you rough idea. It means shortest will be less than 0.4 and this infrared side would be 0.7 plus. Okay? Hello? Yes? Now, see here. Why I'm giving you this diagram? Why this diagram is important? See here. With this, you will also learn one more thing. That is, this is around 4, 4 and 7. So 47% out of the all spectrum is nothing but your visible light. That you will remember. So this kind of detail, is it useful? Yes, it is. Just see the question that was asked in last 2023 May. In the prelims, they have asked this question. One statement was having, the statement was infrared waves constitute more than two-thirds of the solar radiation. More than two-thirds? If two-thirds is this one, if I say two-thirds means 66, this infrared alone, then 47 this one. Is it true? Answer is no. Therefore, that statement was wrong. Therefore, I am giving you this specific detail that you will remember. 0.4, 0.7, 47% is the visible light that you will remember. Okay. And also with the law of scattering, you will come to know this is, see here, this is VIBGYOR. The law of scattering says, the lesser is the radiation, let's say this wavelength, radiation wavelength. If it is lesser, it will be scattered more. It means which one will be scattered least, red and orange, and they will be scattered more. VIBGYOR, that is VIB, that is violet, indigo, and blue. They are going to be scattered very, very high. Yes, and they will be scattered in minimum amount. Okay. Now see here, this is the entire spectrum. This is very easy to remember. Don't worry. This is IMR. You are familiar with IMR? What is IMR? You can remember. VIBGYOR is simple. Before violet, there will be ultraviolet. The only thing that you have to remember this one, gamma and X-ray. Okay, that's it. Now, if we talk about insolation, we have seen the bands. Now we talk about insolation region-wise. Okay. This some importance if I write, see here, this is something which is nothing but in the long wave radiation, they will be radiated, therefore by the earth. And therefore that was also known as infrared radiation. You have seen that visible light is useful for what? To see the things and also for the photosynthesis. Okay, and also this one, blue, it is going to be scattered and therefore what will happen? The color of sky will become blue. Okay. Then, so this is insolation. Some more things about the insolation. Let's say insolation based on, let's say insolation, the earth can be divided into 3 regions. This is the equator. Here it is tropics, 23.5 to 23.5. This is 23.5 to 23.5. This is known as tropics. Tropics means, what is the meaning of tropics? The word tropics means It is the maximum boundary in which the sun can move vertically overhead. So sun will never go beyond this 23.5 north in the northern hemisphere. So this is the maximum. Tropics means to bind something, to limit something. This is the, again, Greek word tropic, means to bind something. So what we have bound in this layer, the moment of the sun. So sun will never go beyond this area. One thing that you will remember, sun never goes beyond this vertically overhead. That you will remember. Beyond 23 in both of the regions. And this boundary, which is binding the movement of the sun, this is known as, therefore, tropics. Sun vertical overhead means exactly over your head. Sun will never is going to be exactly over your head in this area. Because of all other factors we will discuss in upcoming part of the lecture. Okay? As of now, just remember the tropic is the limit in which the sun will remain vertically overhead. Why? We will learn that, don't worry. Next is, now see here, the second region, that is beyond here. It is roughly, you can consider 65 or 60, 65. This is known as your temperate region. Okay, this is 66.5 exactly. That is north. Okay, and 66.5, that is south. This is temperate region. And beyond that, it is known as frigid region. This is frigid region. This is nothing but your temperate region. Okay, so please, we will come back to this area. Okay, after this insolation, I will discuss. We will come back to this one. So insolation is also used to understand the various areas. Maximum amount of insolation, this region. Second maximum, temperate, least amount of insolation here. So this insolation can also be used in order to divide the earth, let's say, in three parts. One, tropics, then temperate, then this one, frigid. Okay. Now, if we talk about insolation, now we are going to see the factors which are affecting the insolation one by one. Write down the factors. Factors affecting the insolation. One more question. Let me give you this question also. See here. One question, then I'll go to the factors. See here. Now tell me where the maximum insolation would be there. In the tropics, yes or no? Yes. Now see here, if I give you the reference, see here, in the near tropics area, if the earth has received nearly 100 units of solar energy, okay, 100. And if I go towards pole, what will happen to this energy? It will reduce. So please remember this one also. So 100 units, if I want to see the distribution towards the pole, so here exactly at 40 degree, somewhat the units would be exactly 79. But you can remember 40, 80. Okay, that will be fine. 40, you can remember 80 units will be reached at 40 degree latitude. Okay. And then it is somewhat here, you will have somewhat around 40 units in the polar area here. Okay, if the entire this equatorial region is receiving 100 units, then the 80 units will be received in this 40 degree latitude, and then 40 units will be received in the upper part, that is near the pole. It means if I compare this polar and the equatorial insolation, how much of the insolation is received by the polar compared to the equator? How much it is the equator is receiving more than the polar area? In terms of times, how many times? More than twice. How much exactly? 2.5 times. Yes or no? Yes. And if I say compared to this mid latitudes, how much it is receiving? You can divide and calculate. Yes or no? Yes. One question was asked by UPSC last year again. They have asked this question as in one statement. They have said that the polar areas, equatorial area receives 10 times more insolation that poles receive. Is it correct? Answer is no. It is receiving how much? Maximum 2.5. So for that reference, now see here, you can have the reference. So for example, can you understand here 100 to 80, then 80 to 40, where temperature is dropping much? faster. It is from here to here. So what will happen in the temperate, and then beyond that, temperature will decrease faster. Okay, so please remember, equator receives, I'm writing here, this is the statement which was asked by the UPSC. Equator receives 2.5 times more insolation energy than poles. Then so this is also you will remember, so that if this type of question is prepared, you will be ready to understand how much would be the drop here. You can compare easily. How much of the drop could be here? You can compare easily. Okay. Then next, now we are going to discuss the factors one by one. The first factor is latitude. Latitude. Now see here, for example, this is the Earth, and here if I make this is the atmosphere. Okay, if I make this is, let's say, the Earth's equator, this is equator. If I want to understand, let's say the sun is, I'm considering the sun is exactly over here. This is the sun, right? So sun is falling, let's say sun rays are falling vertically overhead to this area of equator, yes or no? Yes, so these are the vertical sun rays which are received by the equatorial area. If I talk about this area, more or less it will be receiving slanting sun rays or the oblique sun rays. Now, if we send the same amount, let's say 4 rays I am sending there, 4 here. If you see the coverage, the area which is receiving this 4 rays is smaller compared to the area which is here. Can you see that? Yes. So if I compare these two areas, that is I'm giving the name A1, this is I'm giving the name A2. Tell me where the energy will be very effective, insolation will be very effective. A1, because lesser is the area. And second thing you will remember, see here, also slanting sun rays are passing through the maximum length of the atmosphere, and therefore they will lose much of their energy in the atmosphere also. So which rays are going to be more effective, vertical or the slanting? Vertical sun rays. Why? Because they will be concentrated in a small area, and second, they will go in a very short distance of the atmosphere. Therefore, they will have more heating potential, right? So the two things, latitude based, vertical sun rays are going to be more effective because of two reasons. Number one, because less area receives more insolation. So heating potential is high. Second, vertical sun rays pass through minimum distance of the atmosphere. And therefore they will have much of heat energy. They lose very less amount of heat energy in the atmosphere. Okay. Vertical sun rays pass through minimum distance of the atmosphere, this one. And therefore they will have effective heat with them, more effective heat. And therefore they will be more effective in terms of heat. In terms of their heating potential. Therefore, they are going to be more effective in terms of their heating potential. Okay? They will be therefore more effective. The rays will be more effective in terms of their heating potential. They will be more effective. अभी ठीक है? In heating potential, in terms of heating potential. Okay, number one. So therefore, can I say the poles will receive because slanting sun rays, and therefore what happens is they are not receiving much of the insolation, right? They are receiving therefore comparatively low amount of insolation. Second factor, which is very important, second factor, rotation and revolution of Earth. This is something which is so important. This year also you can have the question from this factor alone. This is so important. Okay? In last 5 years, twice to thrice question was asked from this factor alone. Okay? Let we discuss this one in great detail. See here, just give me 1 minute. I'm not going to draw this 4 diagrams. It will take a lot of time. Let me show you this on digital diagram. I have given you one diagram. Yes, na? Yes. Oh, just a minute, huh? We are happy, sir. Don't worry. Take your time. Climatology. Uh, that PPT is not there with me, I think. Everywhere, same. वेब पे ही ढूंढते हैं चलिए. Yes. So कैसे काम करेगा? Hmm. Diagram suitable one. एटलस वो लाओ ना यार, अर्थ ले आओ, ग्लोब लेके आओ. ठीक, सॉरी. सोच रहा होगा अर्थ क्या लाऊं. आई हैव दैट पिक्चर. कहाँ गया? इतने में तो बना लेते हैं. सो ठीक है, सी हियर. Okay, so let me draw. There is no other option now. This is sun. Okay, here it is the earth. This is the earth. It would have been better, but because बहुत क्वेश्चन पूछोगे नहीं तो आप. Just give me a second. Just a minute. We are so happy, sir. We are getting rest, huh? Just a minute. हाँ, एक तो ये काम आएगा. आएगा आएगा. See here now, see here. Okay. Uh, फर्स्ट वन बाय वन यार डायग्राम बहुत टाइम लगेगा. See here now. The first one is, see here, the first diagram, this is known as summer solstice. Summer solstice. This is 21st of June. That is nothing but the summer month of North India, or sorry, North Hemisphere, right? So this is 23rd North here. It is equator, okay? This side we have, this is 23 and half south, and this is nothing but our, here it is equator, then this is 23 and half north, and this is 66 and half. Here the sun rays are falling over equator, and this is also the sun rays are falling exactly over equator. Okay. Now please understand carefully. See here, the first diagram, if I take first, see here, this one, summer solstice. Now, if we consider the earth, see here, this is nothing but, consider me as a sun. This is the earth. In 3 dimension, the earth is revolving around the sun in this way, right? So this is the back diagram. In order to show you in, let's say 2D, this is I am making here. Otherwise, this is in this way, right? The plane is like this. Now see here, one by one, we will talk about this. So earth is tilted. Can you see that? The earth is tilted. If I take earth here, for example, this is tilted. Yes. Now consider this is the earth which is now not tilted. It is a straight. Right. Now, can you tell me if it was the straight, where the sun rays must have fallen? On the equator, and from equator it must have been distributed equally in both the hemisphere, yes or no? And if from the equator the sunlight is distributed, it will be distributed equally, and it will create same amount of hours in day and night on each and every part on the earth. Can you understand that? This is nothing but, what is the position? Equinox. So what is equinox? See here, equinox is when the sunlight is falling over equator instead of what? Instead of the another areas over equator it is falling. Because of equator, the light is spreading similarly in both the hemisphere. Day and nights are equal everywhere, each and every part on the earth. That is 12-hour day, 12-hour night, equinox. Okay? Now consider in this condition, because earth is tilted, so what happens is, if I just make this tilted, now tell me the same sunlight will fall now on what? Can I say in the northern hemisphere more? Yes or no? Yes, because it is tilted now. Yes. So now instead of equator, see here, this is the equator. Instead of equator, now which is the area comes under direct sunlight? 23 and half now. See here, the sunlight is more here, 23 and half. Can you understand that? Yes. And therefore what happens is, which hemisphere will receive more sunlight? Northern hemisphere. So it is summer for which hemisphere? Northern. And it is winter for southern hemisphere. Done? Now see here, the earth has arrived here. And now see here, the earth is tilted here. Now tell me, instead of equator, if it was not tilted, it was equator. Now because it is tilted, It means which is now going to experience the vertical sunlight? 23.5 southern hemisphere, because it is tilted in this way. Now, because of this more insolation here, it is summer for which hemisphere? Southern hemisphere. And this is nothing but winter for the northern hemisphere. These two conditions are equinox. Equinox means the light is coming directly over the equator. Now, one by one, we will understand. ये समझ में आई चारों position? It is nothing but when the sunlight is falling here. Okay? So what will happen? The sunlight is distributed equally in both the hemisphere. Here also, here also. So exactly half part of the earth will receive sunlight and half is not receiving. Exact है ना? So from this pole to this pole, the sunlight is reaching. ठीक है? Hello? Yes, and therefore this is nothing but, see here, this is known as circle of illumination. Circle of illumination means, for example, see here, if the sunlight is this side from here and exactly without tilt, it is the earth. So what will happen? This half that is visible from your side, this half is receiving what? The sunlight. Rest of the half is in darkness. So this we will say, this is the circle of illumination. समझ में आया? That is the circle which is separating the dark areas from the bright areas, or the, let's say, light wise areas. This is circle of illumination. Now see here, equator. If I say, sorry, equinox. If I say equinox, there are two kind of equinoxes. One is from June. This is nothing but which one? Autumn or spring? After June, what is this month? September 23rd. So this is September. It is autumn. This is winter solstice. The date is 22nd of December. And this is your March 21. That is spring or vernal equinox. Right? Okay? Everyone? See here. One, see here, this diagram. Without tilt. Just consider bina tilt ke. Without tilt. Day and night equal on each and every part. Without tilt. Yes or no? Equinox to hai. Day and nights equal on each and every part. Day and nights equal on each and every part. Yes, na? So can I say variation in the day and night is also because of what? Tilt of the earth? Yes or no? Yes, number one. Number two, let's say consider this is the source of light from here, and if the earth is rotating, can I say the areas which are coming in dark side, they will experience day? Sorry, this light side, they will experience day. Other side, night. So because of the rotation, the areas which are in the opposite side, in the night, they come inside daytime. Can you understand that? Formation of day and night because of rotation. Now tell me, variation in day and night length. Now we will understand that part. One, you have learned tilt of the earth. Okay? Now see here. Please see here. And the first diagram, if I make this diagram, okay, I'm making this diagram separately. This is the diagram. Separate if I make this diagram. So the diagram is like this one. See here now. कर लोगे हैंडल? हाँ यार, कर लो ना यार, ऐसे एक डायग्राम चाहिए मुझे, वो मिल नहीं रहे ढंग के. यस यस यस, आई नीड दैट. एक डायग्राम मैं आपके साथ शेयर कर ही देता हूँ. जस्ट गिव मी अ मिनट, है ना? इट विल अदरवाइज टेक अ लॉट ऑफ टाइम. So if we see the equinox, आपके handout उसमें देखो, in the handout, equinox, just see one box must be mentioned there. In that box you will see equinox is known for, yeah, I found it. PPT भेजूँ आपको, कहाँ पे भेजूँ? इस पे बोर्ड पे चाहिए. मेल पे कराओगे? ठीक है. व्हाट्सअप नहीं है आपके पास? हाँ, पेन ड्राइव में करूँ इसको? हाँ, ये भी सही है, बहुत सही. If you see your equinox, see the equinox in your handout. Equinox is known for the equal day hours and equal night hours on each and every part on the earth. Is it mentioned? Please mark that important. Mention it is. In the box, important points I have mentioned. Just see the equinox. Will you find that? Have you found? Next, on the in case of equinox, where the sun will shine exactly vertical over the equator. Yes. Second. Third, now if we talk about summer solstice, okay, just 1 minute. व्हाट्सअप नहीं है व्हाट्सअप है तो, ऐसे मत करो यार टेलीग्राम है ड्रॉप बॉक्स तो नहीं होगा जीमेल करता हूँ बताओ मेल बताओ मेल आईडी बताओ नहीं है यार ये राहुल है राहुल बाहर राहुल को बुला के लाओ नहीं कर सकते बिकॉज सम नेम्स विल अपीयर वो अच्छा नहीं लगता है ठीक है एंड आई नीड दिस पीपीटी फॉर एंटायर क्लाइमेटोलॉजी सो आई हैव फाउंड दैट ठीक है तो कर लेने थे वो एक बार इज अ मैटर ऑफ जस्ट तब तक दूसरे फैक्टर देखते हैं so what is the next factor jab tak ye ho next factor just drop this factor we will come to the next factor distance between sun and the earth right so we will see that is also there in the ppt but okay we'll do that see here now distance now the two type of let's say because of the nature of this orbit what is the orbit elliptical so let's say sun is here so earth will be sometime far away farthest sometime it will come near see here this is somewhat here. This is the Earth. So what is this position? If it is farthest, it is known as aphelion. Is it mentioned in your diagram? No? Okay. Aphelion. Aphelion, that is 4th of July. Okay. And sometime it comes closer, not that closer. This would be somewhat around 94.5. This would be the distance in millions of kilometers, 91 point something 5. Okay. So not much of the gap is there, but still, yes. And this is known as perihelion, which falls generally on 3rd of January. Okay, so at that time, now tell me, if this is, I consider, it is nothing but winters, na? In the winters, you have seen 22nd of December, which hemisphere was going through this proximity to the sun? Southern hemisphere. Southern hemisphere was inclined towards the sun, and therefore, see here, when it was inclined toward the sun, at the same time, the distance between the sun and earth is also less. Therefore, what will happen? Can I say their summers will be severe? Yes or no? Yes. See here, this is the earth position at that time. The southern hemisphere is more inclined towards them. And this is now, see here, when the southern hemisphere is more inclined, earth is also near. So therefore, what happens is, this summer in which hemisphere? Summer in southern hemisphere will become severe. And this severity increases by around 7%. Whereas in this is winter for northern hemisphere. Can you see? Because we are away from the sun. And at the same time, thankfully, the sun and earth, they have the least distance between the two. And therefore, we are not that much of the severe winters are there in the northern hemisphere. So these winters become less severe. By how much? Again, 7%. In which hemisphere? Northern hemisphere. Okay? That is the point. Here, now tell me, it is thankfully summer for which hemisphere? Thankfully summer, northern hemisphere, and thankfully we are maximum distance away. So the northern summers at this time, aphelion, northern summers, that is north hemisphere I'm talking about, they become less severe again by how much? 7% because of this factor. And this is winter for which hemisphere? southern hemisphere, and their winters will become more severe. Why? Because at that time they are maximum distance away from the southern hemisphere. Getting this? Yes or no? हाँ हाँ मैं आपको कर रहा हूँ सही आपने कहा. What is the next factor? The fourth factor, sun spots. Number of sun spots would be there. Yes or no? Yes, because we are farthest away. Okay. So northern hemisphere, when it is tilted, the northern hemisphere is tilted, and it is now maximum distance between us. Therefore, what happens is we are receiving comparatively less insolation. Okay. If the maximum distance was not there, क्या होता फिर? You must have received more insolation. So this is how the northern summer thankfully reduced by 7%. Northern winter also thankfully less severe by 7%. Okay. Number of sun spots. Next factor. Number of sun spots. आपका handout खोलो. In that, just see this. The factor. Distance from the. No, not that box. Next factor देखो. Factor. यार संतोष ये कैसे आएगा देखो ना. ये शेयर है यार. बिल्कुल पीपीटी ना. शेयर एस अटैचमेंट. एक सेकेंड. हाँ पीपीटी. मैं व्हाट्सअप कर. एक सेकेंड. आपने मेरे को हाई किया ना संतोष. यहाँ पे हो गया ये ना. नो डन. नेक्स्ट लिखा है वहाँ पे सब कुछ. यस done. Next is now next factor is number of sun spot. Now what is sun spot? See here, for example, this is the solar chromosphere. In this solar chromosphere, sun spots are nothing but, you will remember first, they are created. Why they are created? Because of periodic disturbances and nuclear fusion which is going on in this star. Do you remember stars? Nuclear fusion. Now these sun spots are also the cooler spots. They are cooler than their surrounding. They are. And approximately 1500 degrees C, they are cooler than their surrounding. Okay. Now tell me, and there is also one more thing that you will remember. Sun spots follow a 11-year cycle. Okay, 11-year cycle means they will increase and decrease in every 11 years. So this is 11-year cycle that they will follow. Okay, their cycle you will remember for the prelims. Now see here. Yes. Now see here. These are the sun spots, which are more or less darker also. Okay, darker spots they are. Now tell me, if the sun spots are increasing, what will happen to the insolation towards the Earth's surface? It will increase. Why? लिखा है सर handout में. So insolation will increase or decrease? It will increase. Why it will increase? Yes. So what happens is, please do not get confused when I say they are cooler than surrounding. Now see here, cooler than surrounding. For example, why they are created, just tell me first. Why they are created? Because of what? Because of nuclear fusion. It means whenever you see some dark spots are there, they may be cooler than the surrounding. ठीक है? होने दो. But it means what has started on the sun surface? क्या हुआ है? Nuclear fusion has started. Yes or no? Yes. Now you can see and remember this example with the help of one fire. For example, the woods you are burning. Wood जलाते हो? The wood fire. In that wood fire, you may have seen some black spots which are going up in the air. देखा है आपने black suit? Yes ना? If I say, because we have ignited that fire, therefore black suits are coming in the atmosphere. Yes or no? Yes. Now I am saying, compared to the fire, the black suits are cooler around 1500 degrees C. Okay? Hello? Compared to the surrounding fire, they are cooler. Okay, fine. Now I am saying you, the black particles are increasing. Why they must be increasing? Because I am just putting more and more woods and therefore they are coming out. समझ में आया? So what is the origin? The origin of this sunspot is the nuclear activity. And if the sunspots are increasing, it means what is increasing here? The nuclear fusion is increasing. And then what will happen? Solar storms will become more powerful. And therefore, what will happen? You will see the sunspots, if they are increasing, then the insolation will also increase. Yes, that is simple. So please remember for your prelims, if the sunspots are increasing, it means the nuclear fusion is increasing in this entire area. So your temperature will also increase. That's it. Next one, the last factor, I think, in every 11 years, maximum number of sunspots would be there. So at 11 years, you will see the temperature towards the Earth's surface will increase. Okay? In every 11 years, it will come and they will increase in a cyclic manner. And here they are maximum 11 year. Again, they will decrease. And after 11 year, again, they will be maximum. Okay? So cycle. The last factor, I believe, that is the atmospheric factors. The last factor, that is atmospheric factor. Atmospheric factor. Now see here. In the atmosphere, there is reflection. There is reflection. Second, there is absorption. Then there is scattering. Yes. And then there is diffusion also. Diffusion. One by one, we will understand. Okay. Now see here, first is reflection. What is reflection? Reflection means the incident amount of energy is reflected back, right? So please, just for the prelims, you will remember, what is this? See here, this is the energy. If any of the surface is receiving this energy, how much of the energy is reflected back to the, again, atmosphere and space? That is reflection, okay? It is also known as, in geography, albedo. Yes, it is nothing but reflective capacity or reflective coefficient, right? Around of Earth, it is given, है ना, 0.3 or we can say 30%. The Earth's reflectivity is 30%, if you can see. Yes, some more planets have been given. If you will tell me the maximum, let's say the albedo is of which planet in your handout, it must be Venus. Now Venus, its atmosphere is full of carbon dioxide. Okay, around 90% of its atmosphere is made up of CO2, Venus. And its albedo, consider albedo. What is albedo? Reflection. If it is full of CO2, how come then this reflection is possible? क्या है? उसमें कैसे हो रहा है reflection? So there is some matter in this, let's say, planet, which is very much brighter. The chemical matter is there, which is very bright, and it is reflecting this radiation back into the space. Please remember, you can write down this in your handout. Write down in your handout. Venus का कितना है? बताओ. Just write down then there, Venus, in your handout. Albedo देखो. Factor is albedo. Okay. In that, write down Venus is full of CO2. Its atmosphere is full of CO2. Its atmosphere is full of CO2. Full of CO2. But still it has some white chemicals on the surface. Some bright and white chemicals on the surface, which are responsible for high albedo. Which are responsible for high albedo. If you will Google, you will find Venus is the one which experiences highest temperature. Why? Number one, it is close to the sun. Number two, because its atmosphere is full of CO2. Now the question can be given in this way. Venus is the one which atmosphere of the Venus is full of CO2 and therefore it experiences very high temperature. Yes. If I make this a statement, now listen carefully. The Venus is known for very high albedo capacity, but still it is the most warm planet. Yes or no? Why? Yes. Now see here, please. See here, please. Again, I'm repeating. See here. Venus, if you see, this is the Venus, for example, this entire atmosphere of Venus is having CO2, and the surface of this Venus has some very white, bright chemicals. So, what happens is the insolation is reflected, 70% of that will be reflected. But what happens in the atmosphere? CO2 is known for what? Absorbing this, and therefore, what happens is temperature of the Venus increases a lot. समझ में आया? Yes or no? Yes. For the prelims, you will remember, even if the highest is the albedo, is still because of the dominance of CO2 in the atmosphere, this becomes very, very warm. Because of both are there. Reflection from the surface, absorption in the atmosphere. Okay? So both are high. Okay? Now come back and now we will see the last factor. Last में क्या discuss कर रहे हैं अपन? This one, reflection. Okay? So this is reflection. Now see here. In the reflection, two things you will remember for your prelims. Number one, it will depend on what? The color of the surface. Which color will reflect more? Bright and white colors will have more albedo. Bright and white colors will have more albedo. And dark colors will absorb more, less albedo. Okay? Albedo, second factor, is decided by the angle of inclination, angle of sun rays. Angle of sun rays, they are important for your prelims. Okay? Now, angle of sun rays, for example, if the sun rays are falling vertical, then what will happen? Maximum would be the insolation and least would be your reflection. Okay? So, least reflection if the vertical sun rays are there. Vertical sun rays are known for least reflection. No, they are falling on very small area and that is not capable enough to reflect them back. And when they are coming from some angle, see here, the sunlight is coming from some angle, slanting. So what happens is it will be easily sent back to the space. Torch मार के देखिए आपने कभी? Just keep this torch and just see with angles. आपको समझ में आ जाएगा. If the incline is the light, it will be reflected more. So this will depend on, see here, slanting sun rays will be reflected more. Please remember this. Now my question is coming for you. See here. My question is, got this one? 2 points. The one based on the vertical or the slanting they are. Second on the surface color. Some table I have given you based on the, let's say their color, the albedos are arranged. The highest would be in the snow. Second would be in which clouds? Cirrus clouds. In that way, please, for the prelims, try to memorize this order. Okay? Extreme color of this snow, that is extreme white. So they will have more albedo. Okay? Now see here, one question that I am going to ask you. This pole area I am talking about, the pole area. In this pole area, see here. Okay? When I say vertical sun rays, this was for the example. Okay? Otherwise, they receive which one? Slanting sun rays. Now, see here, if I talk about this pole, now tell me, on this pole, 6 months of the day is there. Yes or no? Pole, I'm talking about pole. 6 months day would be there. Okay? If the pole is receiving 6 months of the daylight, then why still it is under the thick ice cover? Why not the ice is melting here? Because of? Why? Because it is highly slanting. Number one, it is losing much of its potential. Yes. Second, reflection. Reflection is maximum. Number one, because of slanting. Second, ice itself. Because of this, even if the 6 months daytime is there on the poles, they will have the ice cover, thick ice cover. Samajh mein aaya? Then next now, see here. We are done with the reflection or the albedo. Now come to absorption. Now what is absorption? When some energy is falling on the surface and surface is not reflecting this time, rather it is keeping some portion with it. So what is this absorption? See here. For example, this is the Earth's surface. Earth is not reflecting that energy, and it is rather using this energy to convert this energy in what form? Heat energy. So if some portion of the energy is kept by any surface, then it will be known as absorption. समझ में आया? The energy which is incident energy here, if some portion is kept by some surface, it will result into heat energy that will become warmer, and this is known as absorption. Got this? So absorption, when I say absorption, can I say water vapor is something which can absorb both incoming as well as plus outgoing radiation? Yes or no? Which one it will absorb rather faster and much efficiently? Outgoing will be absorbed much faster and much better in way, right? So water vapor, also one note will be written there: nitrogen, oxygen, and ozone, they can also absorb this kind of radiation, UV radiations. Yes, now is it written? Yes, so be careful with them. Okay. However, they cannot absorb one more thing must be written there. एक और note लिखा हुआ है. However, they are transparent for what? Visible light. Okay, so be careful for the prelims in this area, right? Next, now scattering and diffused reflection. Okay, diffused reflection, scattering. What is scattering? For example, see here. For example, this is the atmosphere. See here. For example, this is the atmosphere. See here. For example, this is the atmosphere here. In this atmosphere, we have so many, this third component. Do you remember atmosphere's third component? What was that? Third component. That is dust particle, aerosols. Yes. Now they are scattered here. Now see what happens is, please remember this two law of scattering. One is scattering depends on what? Scattering depends on, number one, the wavelength, and that too power 4. Okay, it means which wavelength of radiation will be scattered more? The shortest one, yes. So this is the number one. Number two, you will remember the particles which are scatter particle, this particles. So I'm talking about diameter of this particles, diameter of this particles, of these particles. Which particles? Scattered matter or scattering material. Matter. If it is lesser than the wavelength of radiation, wavelength of radiation, please see here, if the wavelength of radiations is something, and if we compare the diameter of scattering matter, if this diameter is smaller, then what will happen? They will diffuse this light in all the direction, and if the light is scattered in all the direction, we will say this nothing but scattering. So what is scattering? When the light is reflected in all the direction. So we will not use now the word reflection, we will use the word scattering. Reflection is something which will be direction sensitive. This is reflection. But when it comes to scattering, scattering will occur in all the directions. समझ में आया? Yes, so that is scattering. So please remember these two laws. Now this kind of scattering, this law was given by, these laws were given by, for example, there was one man who gave this law, Rayleigh. And the scattering, this law, okay, Rayleigh scattering is the phenomena which was given by him. According to him, the low wavelength of the, let's say, visible light will make them to be scattered more. Okay, so that is the law of scattering. Then if the light is diffused in all the direction, then it is scattering. In one particular direction, then it is reflection. Okay, now what is diffusion? See here, diffusion, see here. Diffusion, or this is also known as diffused reflection. Diffused reflection. Is it mentioned in your handout? Diffused reflection. See here. In case of diffused reflection, along with this all the direction, some portion will be sent into the atmosphere. Okay, and this is known as your reflection component is there na. So diffused plus reflection. So this is going to happen when the ratio will become inverse. So in this case, scattering. And if the diameter of scattered matter is more, then what will happen? It will cause reflection. That is diffused reflection or diffused deflection. समझ में आया? Hello? Yes or no? Again, I'm repeating. See here. Scattering. What is scattering? See here. Scattering means light is scattered in all the direction. All the direction. That is scattering. Okay. Is it color sensitive? Yes, it is color sensitive. Okay. It is also wavelength sensitive. Now, what is the rule or the law of the scattering? One says scattering will be inverse proportional power 4 to the wavelength of the waves. It means if you will put in this formula, the lowest wavelength will be scattered more. And if the wavelength is higher, it will be scattered least. Okay. Second law says if the diameter of a scattering matter, this one, is lesser than the wavelength, it will cause scattering. If it is more than that, then it will cause diffused reflection, where some portion will be sent back into the space. समझ में आया? Now, because of the scattering, what will happen? The color of sky appears blue. Why? Because blue has nothing but the lowest है क्या? It is lowest, or it is violet and indigo. Then why not violet and indigo is the color of our sky? Why blue? Why the color is not violet? Why not indigo? Why the blue? Yes, okay. Why not the color of sky is violet and indigo? Because number one, their proportion is less in this entire visible light, number one. Number two, the eyes of our human being are less perceptible to these colors. Therefore, what happens is the next color we are left with is, which is being scattered more, that is blue. Therefore, it appears blue and blue. Okay? So the color of sky appears blue because of what? Because of scattering. Got this? Hello? These are important areas for your prelims. अगर समझ में नहीं आ रहा है, you can ask me. Scattering, got it? Yes? Now see here, if the scattered matter is slightly bigger, if its diameter is slightly bigger, then what will happen? They will scatter all the lights. And if all the lights are equally scattered, then the color of the sky will become gray. And this was given by Mai. So this is known as Mai scattering. What is Mai scattering? Is it mentioned in your handout? What is Mai scattering? Yes, when the particles are larger, they will scatter all type of lights, and therefore the color of sky will turn gray, and this is known as Mai scattering. If the color of sky is blue, what is scattering? It was Rayleigh scattering. Okay? If the color of sky turns to gray, that is your Mai scattering. Got it? Yes. Yes. होता है. It will happen. Yes, net पे देखना, color दिख जाएगा. Okay. Next now, see here, we are done with the fifth factor. I am going back to the second factor now. Diffuse reflection नहीं समझ में आया? See here. What I am saying is scattering and diffusion are kind of similar. In case of scattering, all the directions, ठीक है, where the light is being distributed, when slightly larger particles are there, slightly, then what will happen? In one particular direction, this will be sent back to the space also. So along with diffusion, this reflection is there. Okay? So that is the reflection. Next now. Yes, the factor number 2. That was nothing but now we have the PPT. See here now. यार ये क्या लगा है? वॉलपेपर लगा के गया क्या? अच्छा, from here. Okay. Now see here. This is the exact 4 diagrams that we were making. I will come back to this diagram. थोड़ा सा रुकिए. This is the diagram that is given to you in handout. This one. See here now. The 4 positions that I was mentioning about. Now see here. Consider this position here. Now can you see this one? See here now. Can you see this one? The earth is now, because it is tilted. See here, the earth tilt. Can you see here? The earth is, because it is tilted towards the north, it is now the 23.5 is experiencing the sunlight. Yes, and because it is tilted, now can you see this entire circle? That is 66.5 it is. 66.5 north. It is now, you can see here, this is the circle of illumination. Can you see this? From here, the daylight is there. From this side, we have the dark side. In that case, now if I show you, see here, this diagram, we also have separate, but first understand here, this is here, we have 23 and a half. So 23 and a half is receiving more sunlight. Now, just see here, just give me one more minute. There is another diagram also. Yes, now see here. This is exactly, see here, because of the tilt, because of Earth's tilt, see here, because Earth has tilted here, the sunlight is here, exactly. Sunlight is exactly here. Yes, now the circle of illumination is here. This is circle of illumination, right? Now, in this case, can you see this entire 66 and N is nothing but in which side? In the lighter side. If you see this entire area, see here, this is the half part, this is the equator, this is some more areas there. Now see here, if I ask you on the equator, see here, exact half of the equator is in the brighter side. This represents 12 hours of daytime. Exactly half is in the darker side. That represents 12 hours of night. Can you understand that? Equator means always day and nights are equator, no matter what is the position of the earth, irrespective of the sun and earth's relation, always this will be 12 hour. Okay? Therefore, it is equator. Okay? Second, if I go to the north, see here, if I am going to the north, what is this area? Tropic of Cancer. Now, 12 hours, this one, representing 12 hours. Yes? Now, see here, this additional means some 2-3 hours more. Yes or no? Yes. It means, can I say here, the daytime is more than 12 hours? Yes or no? Yes. If I consider next area, see here, this is the additional hours in the day. Yes or no? So, the day is increasing. And now, see here, what is the length of the day here? 24 hours. This area beyond 66 and half is in the daylight only. Can you understand that? Yes or no? Yes? Hello? Therefore, the land beyond this area is known as land of midnight sun. Why? Because even in the midnight as well, the area will be under the sunlight. Yes or no? Tell me yes or no? Yes. Now see here. If I am going from equator to the North Pole, what is happening to the sunlight? Is it increasing? What is going to happen to the day hours? Are they increasing? Yes or no? Yes. And from where exactly? From this 66 and half, the day time will become more than 24 hour. And this pole areas, I will show you, okay? They will experience more than this 24 hours always. Now see here. If I go back in the southern hemisphere, now see here, this half represents, let's say the 12 hour. Which area I'm talking about? Let's say 23 and half. Now see here. This is nothing but here. This half is 12 hour. This from here. Okay? Can I say the night is longer here? Yes or no? Yes. The day is becoming smaller, and from here onwards, can you see this here? That is 66 and half south. From here onwards, there is no light at all. That area remains under permanent darkness. Yes or no? Yes. So please, what you have to remember, in case of this summer solstice, northern hemisphere side, if you will go, the day length will increase. And if you are going toward the southern hemisphere, the day length will decrease. समझ में आया? Because it is tilted, na? See here. Because it is tilted. See here. See here. Because of the tilt, what happens is, can you see this? ये visible है? Because of the tilt, can you see this entire area? That is here I'm talking about. See here, the area I'm talking about. Yes, the area which I'm talking about, see here, this area. Can you see this? Yes, because of the tilt, this entire area. Dikha? This is 66 and half, that is south side. Because of the tilt, it is outside from this area of the brightness. Okay? So it remains under the dark time. And because of the tilt only, the area is always under the light. Hello? पढ़ के आयो geography? Foundation करा है कहीं पे? Have you have this basic knowledge? Yes or no? Yes. Now see here. Again I'm repeating. See here. Because of the tilt. Now see here. One more diagram I have. Yes. See here. This is the diagram of equinox. See here, in this case, what is the circle of illumination touching both poles? Yes or no? Yes, every part. This represents 12 hour, this represents 12 hour, this represents 12 hour. Every part on the earth will have exactly half daytime, half nighttime. In case of summer solstice, it will incline. If it is inclining in this way, can I say this portion will go this side? More area from the brighter side will come in the darkness. Hello? Yes or no? Yes. Now see here the diagram. See here the diagram. Because of the tilt, the southern hemisphere is tilted away, northern hemisphere is towards the equator. Now please remember, because of this factor, see here, because of this factor, you will have now your box and just stick these points in your box. See there in your box. See your box now. In summer solstice, in your box, it must have been written that northern hemisphere will receive more insolation and therefore it is the summer. In your box mein likha hai? Can you see that? Second, see here, it must be written from equator to North Pole. Please remember, which pole? North Pole. What will happen to the day hours? They will increase. Is it written? It is from 66.5 onward, the day will become more than 24 hour. Therefore, it is known as land of midnight sun. Are they written? Yes or no? Yes. Mila? Entire this area is only sunlight, na? बाहर पूछना आप, बाहर पूछना, ठीक है? It will be more than 24 hours. इसी फैक्टर में क्लास खत्म हो जाएगी नहीं तो, ठीक है? Done? Yes? This is summer solstice. Okay? And if you go in the southern hemisphere, instead of day hour, what is going to increase? Night hours will increase. Okay? So now one very simple question was asked by UPSC, I think in 2024. This question was, they have asked where the length of the day would be more than 12 hours. They have mentioned this 4 position. In case of summer solstice, they have asked, in summer solstice, where the length of the day would be more than 12 hours. Just tell me the location. Number 1, equator. Is it correct? No. You have to be careful. Equator means always 12 hours. This is not true. Second, if I say 23.5 south. Yes or no? Answer is no. Southern hemisphere will have, see here, this is standard 12 hours. This side more than 12, this side less than 12. Okay? Now, third, 23.5 north. Yes, and what about this one? 66.5 north. Yes, so that was the question. Simple? Samajh mein aaya? Yes. Now, if we talk about southern hemisphere, this one, winter solstice. Now, in this winter solstice, what will happen? Are these points covered? Summer solstice wale, everything is covered. Can you understand that? Yes, please remember, northern side, more day hours, and just see the location, 24 hour. This one will represent 24 hour. This one will represent 12, in between 12 to 24, beyond 24. Okay? Now come to the second diagram. That is the winter solstice. This time, see here, this time, the earth is tilted towards the sun in this way. Now tell me, which hemisphere is close to the sun? Southern. It is the summer for the southern hemisphere, winter for the northern hemisphere. If I consider this diagram, see here, if I consider this diagram, see here, if I consider this diagram, here it is equinox. Each and every part is receiving equal amount of energy. Okay. Now I have to tilt this in this way. Tell me, which hemisphere will come more in the darker side? Northern hemisphere. Which hemisphere is going to come more in the brighter side? Southern hemisphere. Therefore, day length will increase in the southern hemisphere. Night length will increase in the northern hemisphere. That is it. Now see the diagram, the same diagram. See here. See here. Because it is tilting more. Can you see this area? See here. Focus on this area. Can you see this much of the part of southern hemisphere is now under sunlight? Therefore, it is summer for them. Only this much is in the other side. Therefore, it is the summer for southern hemisphere. Most of the part that is of the northern hemisphere is away from the sun. Therefore, what is this season for us? winter for us. Now see here, if we go by the logic same way, see here now, if this is representing equator 12 hour, okay, if this is the axis, see here, exactly this is the axis, this is 12 hour of day, that is 12 hour of day always. Now see here, the 12 hour of the day here also, but additional hour. Can you see this? Can you see this additional hour here also? Yes. Can you see entire this Arctic circle here? It is in the sunlight, yes or no? Yes. So this is 66.5 south, and beyond which there is no concept of night. There is always the sun is there in the midnight also. Sir, can we also say this land of midnight sun? No, there is no land in the southern hemisphere. Therefore, you will not say land of midnight sun. नहीं कहोगे. The land of हाँ sea कह लो. ठीक है? Now see here, in this side, see here. This is nothing but here, Tropic of Cancer. This is representing how much? This must have been 12 hours. Yes or no? Yes, but this area is receiving darkness. Therefore, less than 12. This is entire, this area is nothing but in darkness. समझ में आया? So now see here, in winter solstice, southern hemisphere side, if you will go, 12 hour, it is increasing, 12 hour plus in this area, that is 66.5, 24 hour, and here 24 hour plus daytime. Yes, got this? Tick your box now. In winter solstice, 23.5 S is receiving the sunlight. Okay, 23.5 is south side is receiving the vertical sun rays. The winter for northern hemisphere, summer for southern hemisphere. Then box mein, it is written in your box. Written in your box. Then if we are going in the southern hemisphere, day length will increase. And if you will go in the northern hemisphere from equator, the night length will increase. Done? Now come to rotation. Tell me, rotation is responsible for the day and night formation? Yes or no? Yes. Then come to the variation in day and night length. So variation is caused by what? Number one, rotation itself. Yes. Number two, it is nothing but the yes, inclination of the earth. Yes or no? Tilting. Third, can I say revolution of earth also? If it was here, the daytime was here more in the northern hemisphere. If it was here, the daytime was less in the northern hemisphere. So revolution also. Yes or no? Yes. Formation of season, tell me. Revolution and other things are written. 4-5 factors are there. Dekho, formation of season, what factors are mentioned? Number one, tilt. One by one, let me discuss. Tilt, is it responsible for the seasons also? See here. If there was no tilt, see here. If there was no tilt, this was same equinox condition in both the hemisphere. Because of the tilt, summer. Because of the tilt, winter. Can you understand that? Tilt, is it responsible? Yes. Second, revolution. See here. Because of revolution, this position came. Because of revolution, this position came. Because of revolution, this position came. Yes or no? Yes. Then, is it given parallelism? Now, what is parallelism? See here. The earth is axis, if we see, this is tilted axis, this one, pole to pole. You will see always it is pointing in the same direction, no matter what is the position of this earth. So, always pointing in which direction? North side, north side, north side, north side. Now, how it is important for the season? For example, this was here, but instead of going in this way, it has reached in the same way here. क्या होता फिर? Same season must have been there on the in the southern hemisphere or northern hemisphere, both? Yes or no? Yes. See here, what I'm saying is, this is the axis pointing towards this direction. Now, instead of pointing in this direction, if it was coming, and this is now how it is pointing, then what could have happened? Still the northern hemisphere is experiencing the sunlight. It is therefore, can I say, the parallelism that remains always in this way is also responsible for the formation of season, yes or no? Yes. So these are the all factors that we have learned. Factors of insolation. समझ में आया? Yes. If you have any doubt, you can ask me, because this is so important. Question is something which will come from this area. If you have any doubt, if I ask you, see here, some questions, let me ask. Rakh do apne handout. Let me ask some of the questions. Very simple questions. Tell me, which of the following areas are going to receive 24 hours of night time in winter solstice? Huh? 24 hours plus in winter solstice. First, tell me which hemisphere will have more night, north or south? North. It means which areas you will select? The northern side. है ना? Northern side means 24-hour plus. 66 and half north? Yes or no? Yes, 24 it is, not plus. 24. Beyond that area, 24 plus. समझ में आया? दिखा देता हूं मैं आपको. See here. See here. यार ये क्या बनाया आपने मेरी पीपीटी से? व्हाट इज दिस? ये क्या बनाया है? पीडीएफ बना दिया है. पीपीटी है ये, तो उसमें वीडियो कैसे चलेगा? ये तो वीडियो था. यस, इफ यू वांट टू सी योर कॉन्सेप्ट्स, देखो इधर. ठीक है, वीडियो आई विल प्ले. ठीक है, सम डे लेटर, बिकॉज उसमें टाइम लग जाएगा बहुत ज़्यादा. मैं आपको दिखा दूंगा. सी हियर, दिस इज समथिंग दैट यू कैन see and check with your knowledge. See here, if the length of the day, if I consider on the equator in March equinox, what would be the length? Tell me. ठीक है, so this is, you can check your concepts with. If you want to take picture, you can take. ठीक है, try to solve these questions, whether you are able to solve this or not. ठीक है. This is very important. It will give you the understanding whether you have learned this concept or not. हाँ ठीक है, कर दोगे शेयर पीडीएफ? कहाँ पे करनी है शेयर? पोर्टल पे, पोर्टल पे करवा देना. राहुल को बोल दो. हाँ मैं समझ गया. आई विल से दैट टू अरविंद. ओके, डन. Now we are coming to the next area then. Insolation is over. One last area we are left with, heat budget. Heat budget. What is heat budget? See here now. ठीक है. Heat budget. Okay. In the heat budget, what is heat budget? Anyone? It is nothing but the balance of incoming and outgoing radiation, right? So in that, one diagram is given in your handout, that is from the NCERT I have given you, right? In this diagram, if you will see here, in this diagram, what you will see, for example, we are assuming 100 units are reaching from the, let's say, solar insolation. And if I see, this is the incoming side, okay? See here, incoming side. This is the Earth's surface. How much of the energy will reach? We are going to discover that. Now see here, out of 100 unit, first is 27 units will be reflected back by a cloud. And 2 additional units will be reflected from the Earth's surface. That is 29. Rest of that, what we are left with, 34 units are going to reach on the Earth's surface in the form of direct radiation. Yes or no? Then 14 units will be absorbed by atmosphere. And rest of this 23, they are scattered. Out of this 23, 6 will be sent back to the space and 17 will be coming on the Earth in the form of diffused daylight. दिया हुआ है diagram में, just match your diagram. Now see here, this is how much of the units are coming on the Earth's surface. If I add, this is 51. Okay, 51 units were received by the earth total. How much of the units are received by the atmosphere? 14. Okay, if I talk about the outgoing side now, so earth has how much units? 51. Out of that, now earth will radiate in the form of radiation. Which radiations they are going to be? Long wave. Now tell me how much it is radiated. It is again 23 units. Yes or no? In your diagram, dekho. Yes. How much of the atmosphere is absorbing out of that? 17. 6 are going to the space directly. So this is space, okay? Here I am talking about in the part of atmosphere. 19 will reach in the form of what? Convection and turbulences. 9 in the form of condensation. So 19 plus 9, see here, it is written all in your document. So now if you see the atmosphere, how much of the energy has received by the atmosphere? From the bottom side, from the below. Total 17, 19 plus 9. How much it is? 45? Yes. And if you see from the incoming side, how much of the energy was received? 14. If I ask you this basic question, from where the atmosphere is becoming warmer? From upper side or from below side? From below? Yes. So please remember this thing. For the atmosphere, the primary source of heat is not the sun, it is the earth. And that is here you can see from the earth's radiation, it is receiving much of the energy. समझ में आया? So one thing that you will remember, that is the atmosphere of the earth becomes warmer primarily because of the earth's surface. समझ में आया? Because of this much of the energy is coming from the earth. Okay, so that is the heat budget. Done? Now see here, this is the heat budget. It is given in your NCERT. However, it is incorrect. Why it is incorrect? But आपको यही पूछा जाएगा. Because it is given in your NCERT. Why it is incorrect? Because it is not taking into the account of this counter radiation. Counter radiation kahin mentioned hai? Answer is no. Because the counter radiation, what is counter radiation? Some of this, let's say, radiations will also come towards the earth surface, yes or no? When it is directed, they will also come back. Now, what will happen to this energy? Nothing has been shown in this diagram. समझ में आया? So this is incomplete rather. And this new model was suggested. This is for the optional, not for you. Oliver and Hilder model. They suggested that this counter radiation is also there. But आपके में नहीं है. Okay, so for your GS purpose, only this much is sufficient. Okay, this is your insolation. Yes. But primarily, see here, from where it is getting more energy, only 14 unit from the upper side and maximum from the lower side. Okay, done? Everyone, insolation is over. We are going to the new chapter then, longitude and diffuse daylight. Abhi abhi baat kar rahe hain na, scattering, diffusion. So because of the diffusion, what will happen? The light will be diffused and scattered in all the direction. So this is the reason, the daylight. Daylight. आपको जो दिखता है, that is the light. ठीक है? So 17 units are reaching in the form of daylight. And if you see, one more diagram must have been given in your handout. If you see the balance of the heat, so this must have been the diagram. 40 to 40 दिया हुआ है. 40 to 40 remains in surplus. And this will remain in deficit. Beyond 40, deficit. Beyond 40, deficit. Then some variations must have been given. Latitude wise variations, season wise variation. Yes, na? Insolation depends on seasons. Yes, we have seen. Insolation also depends on latitude. So some variations are there. वो बस मैंने आपको दे दिए हैं in your handout. Some variations, okay? So with this, we are done with the insolation chapter, right? Just tell me, is this rotation and revolution factor clear to everyone? Yes or no? If you have any difficulty, ask me, because this is the potential area. From here, the question will come. Okay? Next now, the next chapter, latitude and longitude. And longitudes. Latitude and longitudes. What is latitude first? Tell me. We are starting with latitude. It is imaginary or real lines? They are imaginary lines, okay? Imaginary, yes. Horizontal means what? Imaginary lines which run, imaginary lines which run parallel to what? Parallel to equator, yes. Imaginary and equidistant line. Equidistant line which run parallel to equator and also to each other. To each other. Okay. Now, what is the importance of this latitude? For your prelims, what is the importance? Number one, it is used in what? In measuring distance. How? Because every 1 degree of the latitude is separated by 1 kilometer. Okay, number one. Number two, it is also used in knowing climatic conditions. For example, if I say I am right now at 8 degree north latitude, what you will understand, where am I right now? कहाँ पे हूँ मैं? In which climatic conditions right now I am? Can you understand? The insolation will be high, rainfall will be high, yes or no? Yes, so in that way, the latitude will give you the two information. Number one, it is the distance. The second, it will also give you the idea about the climatic conditions, right? Number one. Now, if we go to the second part, that is longitude. So latitude we have learned, that is nothing but if this is the earth, equator means exactly half around, let's say you can cut this earth into exactly half. The latitude means this is 1 degree, 2 degree, 3 degree, 4 degree in that way. Okay, every 1 degree is separated because they are equidistant. So 1 kilometer they will measure. Okay, longitude now. What is longitude? Can you give me the definition? Again, they are imaginary lines. Yes or no? Tell me now. I have given you one definition. Second, you will give me. बताओ क्या है? What is longitude? Yes. क्या क्या ज्वाइन करेगा पोल पे? The lines which are joining at pole. Okay. They run east to west. They are all around, ne? Yes. Then west to east run. वो अर्थ है. They are not, this lines are rotating. Earth is rotating. Okay. Yes. Definition. What is longitude? Okay, connecting the poles, right? Are they equidistant and imaginary? Are they imaginary? Equidistant? No. See, this is, they are not equidistant. So please remember, they are not equidistant. Number one. And they run pole to pole. Pole to pole. And they intersect each other at poles. They intersect each other at poles. Okay, so it means they are going to converge at the pole in this way. So see here. They are running parallel. Are they? They are equidistant. Are they? No, they are not equidistant. If you will see at equator, the maximum is the distance. And as you are going towards the pole, the distance is becoming 0. Okay, they are converging here. They are converging here. So these are longitudes. Now, what is the practical application of the longitude? Please see here. The distance between the two longitude maximum here. And it is minimum, that is 0 here. Okay. Now tell me, what is the use of longitudes? Quickly batao. How you will calculate this with this time? कैसे use करोगे? Time calculation, time and date measurement. Yes, na? Okay. Tell me how you will use this. For example, 360-degree rotation is done by Earth in how many hours? In 1 hour, how much it will? 15 degree. If I convert this into 60 minute, 15 degree. 1 degree for 4 minutes. So there are 360 this longitudes. 360 rotation. If I convert each degree, it represents how many minutes? 4 minutes. Okay. Now if I say, see how to use this one. So two use would be there. Number one, the time and date measurement. Number two, it will be used in coordinates. Okay, second will be used in coordinates also. Now see here. For example, if we say this is the GMT, what is GMT? Greenwich Mean Time. It is also known as International Standard Time, GST also. So all are the names now. See here, for example, this is 0 degree longitude, right? From where it is passing? From where it is passing? Do you have Atlas? Atlas hai? Just open your Atlas, page number. You will open page number 92 and 96. Africa. 92 and 96. 92 and 96. Just try to locate this 0 degree and tell me from which lake of Africa this longitude is passing of 0. Which lake it is? What is the lake from where it is passing? Yes, can you find that? In Africa, try to locate 0 MT, GMT. Have you got this? Lake Volta. Have you located? Can you see the equator also in the Africa? Equator? GMT first. Try to locate GMT. Volta Mili? Yes, Lake Volta. Now see the equator. Equator. From where this equator is passing? Lakes, dekho, lakes. Victoria, is it passing through Tanganyika? Is it? Lake Tanganyika? It is distant away, yes or no? Yes. So this is the map work that you will do. So what is the your work, homework? See which kind of areas are important for your mapping. Please try to write down somewhere which areas you will work on. Number 1, you will locate various countries which are opening in Black Sea. Countries which are opening in Black Sea, comma, Caspian Sea, comma, Mediterranean Sea. Mediterranean Sea. This is the very important area for your exam. The countries which are sharing their border with Black Sea, Caspian and Mediterranean Sea. Okay, number 1. Number 2, the areas which you will focus, the areas which are in news because of civil unrest, political disorder, because of some war, for example, areas captured by Russia of Ukraine. The another comma, the areas which were in news because of some big conferences. For example, let's say somewhere the G20 was there, somewhere the WTO meeting must be there, somewhere the UNFCCC's meeting would be there. Yes, na? So the areas where important conferences have taken place. Okay. And the entire Middle East. Middle East. Okay. Then in the southeast side, they will give you the various kind of arrangement. They will give you these countries arranged from north to south in that way. Capitals and countries of Southeast Asia. Okay. For example, if we will go back and see the question, they have asked this repeatedly. What was the question? See here. They have asked which of the Asian country is not joining its border with the Mediterranean. Asian country, right? So please remember, these are the countries which will open in these countries. Oh, sorry, in Mediterranean. Silt country. What are these silt countries? The Asian countries which are opening in the Mediterranean. Open your page number. You will open your page number 76 खोल के देख लो, 76 and 80. Third, fourth edition 76, rest of you 80, page number 80. 76 and 80. Please come up with your atlas if you are coming in geography classes. I will suggest you. Share with somebody, please. Share with someone. Can you see this Mediterranean here? Is it mentioned clearly? नहीं है? So go back to, if it is not, अच्छा ये यूरोप में नहीं दिखेगा. Just go to 66 and 70, page number 66 and 70. Go to page number 66 and 70. New editions 56, 70. Now I think you will probably see which countries, silt countries. Can you see the Asian silt countries are joining the Mediterranean? Syria, Israel, then Lebanon, and then Turkey. Can you see this? Except this for any other country. Jordan, is it Jordan sharing its border? Answer is no. This question has been asked thrice by UPSC. Thrice. So just remember this silt, that is it, ho gaya. In that way you will make the techniques. Okay? How many countries are sharing their border with the, just tell me, Caspian Sea. Just tell me, Caspian. You will locate the Caspian, same in the area, Mila? Are they, how many country would be there? GU. Georgia, is it? Just see the Georgia. Is it? Ukraine? No. Is it Turkey? Turkey? No. Then see the Black Sea now. Black Sea. Can you see Black Sea? Black Sea, Mila? In the same area only. Black Sea. Black Sea. See Georgia. Then Ukraine. Turkey. Russia. Bulgaria. Algeria. Or Armenia. Armenia or Algeria? Armenia. Yes. नहीं? हाँ? अच्छा आपको याद है, mnemonics बना रखा है. Okay, good. Have you found that? So these are the areas which are very important. Okay, the countries opening in Black Sea, countries opening in Mediterranean. Then you will also focus on this straits, the gulfs and straits in the water bodies. Okay, last area that you will write down. Gulf and strait. What is to focus on your mapping part? Okay, Gulf and straits. Gulf and straits. Okay. For example, if I ask you Strait of Bosphorus, where it is? So you will focus on these areas, right? Now come to the next one. See here now. See here. This is the GMT. If I divide this earth here, see here. The earth is rotating from west to east. So this side I'm taking, this is the east. And here I'm taking, this is the west. If I see this is 180 degree, if I see this is 180 degree, okay. Now can I say this is 12 hour, 180 degree means how much? 12 hour? Yes or no? Yes. Here it is also 12 hour? Yes. Now see here, if this is the GMT, here the time I'm giving you, let's say this is 12 AM. Okay, 12 AM and the date, let's say, what was the date yesterday? आज क्या date है? 4th, let's say this is 4th December, na? 4th of December, that is 12 AM in this area. Now just tell me, 1 degree means 4 minutes, right? Now tell me, what is going to be the time in this area, let's say at 180 degree east? What is going to be the date and time? Batao. And time. Tell me, what is going to be the date and time? It will be ahead or it will be backside. It will be ahead. So please remember, this will be ahead in time. Ahead in time. Okay. This will lag in time. Yes, lagging in time. Now tell me, what would be the date and time here? And what would be the date and time here? That is exactly at 180 degree east and west. This means 12 hours you will add here. 12 hours. Just tell me what is the time? 12 PM. Okay. Date? Fourth or fifth? Fifth, how many? Fourth? 4. 4 बजे का 12 नहीं, 12 बजे का 12 बताओ. Fourth. Fourth. And what is here? Acha, according to you, how many says 5? 4? Why 4? See here. This is the same day, na? In the night, date has changed. So in Britain, just now the date has changed, 4th December. If you are coming here at 12 hour, afternoon of the same day, na? Yes, so this is going to be 4th of December only. Now tell me here in this side. This is going to be now 3rd. Yes, na? 3rd, what is the time? 12 PM or AM? This is PM. AM कौन कह रहा है? Why? 12 hour ही तो minus करना है ना? Then what is the date and time? This is 3rd is the date, 12 PM is the time. Yes? Easy? Yes? Now tell me, if I say with the same logic, see here, with the same logic, if I ask you, see here, this is ahead, means it is moving 12 hours ahead. Here we have the afternoon of the same date. Here just now the date has changed. समझ में आया? This is ahead, that is, this is ahead, okay? This is ahead. Just now the date has changed here in this area, but this is 12 hours already ahead in the afternoon of the same day. This is just now the date has changed. Still it is in the back date. Okay. Now tell me, if I see this area, see here. Let's say this is America. Here it is America. And let's say this is the South America. This is, we have here, some of the islands are there, so many islands. So you will see one line is passing from this area. That is going to be zigzag line. Can you see that? Yes, this is the zigzag line, nothing but it is also known as international date line. Now see here, if we say this is somewhat GMT here, that is Africa and Europe, if we say this is GMT. If I go this side from the GMT, American side, that represents how much? 180 degree, which side? It is west to GMT, okay? This is 180 degree west to GMT. This side, if I will come from the GMT, that side, it is still this side I'm talking about. This is China and all, here they are. This is representing 180 degree east, okay? Yes, now see here. Can I say this is nothing but this side we have nothing but 180 degree east only? Yes or no? Because here we have the Alaska. Yes. So see here, this is 180 degree east, okay? Now here I'm giving you the task. Tell me if this is 24th of December. Okay, and the time is 202. What is your prelims date? 24th of May it is in this area, and let's say the year is 2026, right? This is hypothetical, okay? Now tell me what would be the date and time in the western side, sorry, eastern side and western side. First tell me eastern side, this side. Time नहीं बताया. Okay, time is 12 PM. 12 PM. Time, if you will go this side, what is the time? Ahead? Ahead, na? Ahead. So this is ahead. How much it is ahead? This is 12 AM. What is the date? This is 25th. It has converted into 25th. Night ho gayi, night. Date has changed. Okay, 25th of 26 May. Okay, what about this side here? It is still 24. Yes, and what is the time? 12 AM. Very good. Now if I see here, this is the line. Now if I see this side of the line, the date is 24th, and here what is the date there? 25th. There it was 25th, na? Yes. Now see here, if I cross this line from this side, means from this western side, from the American side to the Japan side, the date is changing from 24 to 25th. And if I am crossing from this side, that is date is changing from 25th to 24th. Now tell me, if I am going from 25 to this side, 24, I am gaining a day or losing a day? I am gaining an additional day. I will celebrate again my this prelims there. Yes or no? If something happens in the prelims, you can cross this date line. Okay, reappear. So this is you will gain a day. If you will cross the line in this side from here, that is from the eastern time zone to western time zone. And if you are crossing from this side, you are going to lose a day. Can you remember that? Yes. Now one question was given in your prelims, very easy question. Just see this question and try to solve. In the back, mila hoga ye question. I think 2 questions were asked. Have you found that? Try to solve that. Solve that and tell me the answer. हाँ बट आप समझ के देखो. Can you solve that? Just give me. A is in Siberia. Okay, where is Siberia? Russia. So A is here. Okay, A is here in Siberia. And Nome is in Alaska. N is here in Alaska. Okay. Few kilometers from each other, but when people are waking up and getting set for breakfast in these cities, it would be different days. Is it true? There will be different days. Yes or no? Yes. Date is here. What is the date? 24th. Here it is because they are opposite side to the date line. Okay, number 1. When it is Monday on Anadir, here, है ना? Monday. If it is Monday here, it would be Tuesday here. Is it true? Is it true? No. What should be here? Sunday. So it is the first option is correct. Okay? Gain a day and lose a day with that sequence. Okay? What will happen here? You will gain a day, na? You will gain a day. If it is here, क्या दिया इन्होंने? Monday दिया है ना? So here it should be Sunday. Gain a day. You will go back to the Sunday and again you will enjoy your Sunday. So you are gaining your Sunday back. ठीक है? पर आओगे तो 2 दिन का लॉस हो जाएगा वापस. Okay? That is the one question. Any other question? This is 2025's question. Very simple question. Yes, fine. That is the only question, right? Done. So this is now the last question. Just tell me why the IDL, international date line, is zigzag and not straight. Because some of the countries are here which are in the middle. Here, this is the country. So if this side the date is 25, this side the date is 24, how they will declare holiday? ठीक है? The half towards America they will enjoy tomorrow. Rest of you will come. ऐसा बोलेंगे? नहीं ना? So that way, in order to avoid this confusion, these countries were given the option whether they want to go with the east side or with the west side, they can choose. So they have chosen in that way. For example, this island has decided I will go with American time. So line will pass in this way. Can you understand that? If the island is here, it has chosen the Russian time side that is here. So this ideal will go in this way. Okay. So in order to remove this confusion, this liberal, let's say, deviation was allowed, and in that way ideal became nothing but a zigzag line. Next, now we are done with these 3 chapters. Next chapter is we are starting with temperature. With each question that you are solving, you can understand the importance what we are discussing. Okay, each chapter is important for your prelims. Each chapter is so far giving you 1 or more questions. Insolation, almost every year 1 question is coming. Okay, insolation. The factors that we are going to discuss now in this class, they are so important you can expect a question from these factors alone. Okay? many in my batches in last 2 years or 3 years, I have been saying this one, horizontal distribution of temperature is important. I said na, in your batch also. Isotherms, do you remember? For prelims, I have mentioned in your batch also. Yes, the question will come. And both of the year question came from that area. Okay? So important these factors are. Now see here, temperature. So the factors that are going to affect, this is going to be the one area of discussion. Second area of discussion is going to be its distribution. When it comes to distribution in the prelims, that is so important, especially vertical and horizontal distribution. Horizontal is something where you will learn about isotherms and their importance. This isotherm, this horizontal distribution and isotherm, there was question in 2024, there was a question in 2025 as well in the prelims. Okay? Maybe this year you may not see the question from this area. Rather, the question will be framed either from here, very high possibility about temperature inversion and the vertical arrangement of the temperature. Temperature inversion, very high possibility, and the possibility then it is of factors. The one question, it is coming from this temperature. The high possibility is, this is important. We will discuss that one also. Very high possibility, the question will be asked from this two. Okay? It is again important. I am not saying ki do not cover this. This is also important, but the possibility is very high from this area. Factors first. Number one, temperature distribution we are working on. Number one, latitudes. Latitudes. This is equator. Here it is pole. Tell me what was happening in terms of insolation. Just now we have finished. Insolation was decreasing towards the pole or was increasing? It was decreasing. So if the insolation was decreasing here, what will happen to the temperature? If the insolation was decreasing, temperature will also? Yes. So from equator to pole, temperature will always decrease. Yes or no? No. It is no. Yes. Yes, no. My no is yes. Okay, see here. So see here, I am saying in general, I am putting the word in general. What happens is from equator to pole, temperature should decrease, but there is some exception. What is this exception? This subtropics. In the subtropics, what happens is temperature rather than decreasing, temperature will be highest in this area. So exception is this one. ऐसे ही yes मत बोल दो मैंने कुछ बोल दिया तो ठीक है. So be careful. Now in general from equator to pole temperature reduces. Why? Temperature, I am putting here condition apply. Read the document very carefully. Subject to market condition and risk. Equator to pole temperature will decrease due to decreased insolation poleward. Yes or no? Poleward. Except, what is the exception? Exception is subtropics. Now, can you tell me why the subtropics will have maximum temperature? First, tell me why not equator register maximum temperature for your prelims? This is important. Why not maximum temperature? Why? Number one, because of cloudiness. Yes, because of cloudiness, what happens is the clouds will not allow much of the insolation to reach. They will reflect, and therefore the surface, that is equatorial surface, will receive less insolation. Number one. Number two, yes, very good. The second is the rainfall, that is continuously on daily basis there would be rainfall. Yes, na? So a lot of rainfall will release the temperature. Yes. Then third, vegetation क्या करेगा? ITC, जो पता है कुछ भी जो आता है सब बोल दो. ITC, हाँ, फॉरेस्ट, ऑर्गेनिजम्स, हाँ, किससे रिलेटेड है? हाँ, इसी से ही रिलेटेड है. देयरफॉर आई एम आस्किंग, इक्वेटर से ही रिलेटेड है. Third one, before you give your argument, see here. Third one, see here. What is the third reason? Whatever the insolation is reaching now, ठीक है? Maximum insolation energy will be used in what? Will be, Yes, it is going to be used in evaporation. And because of all these three factors, equator will not register maximum temperature. Be careful with this. It is important for your prelims. Now the same question in different manner. Why the maximum temperature here? Yes, number one, the upper air is sinking here. So air is sinking. Therefore, what is the condition of the pressure here? High pressure, right? The air, if it is sinking, what will happen? Compression. The air will become warmer, and therefore what happens is temperature will be high. Number one, air will become warmer. Second, do you understand when the air is going up, it will expand and it will cool down. When the same air, the cold air will come down, it is rather than expanding, it is shrinking. So what will happen? It will not only compress, but also it is shrinking in terms of its density also. So what will happen? It will go through high temperature, right? Temperature will increase. Number one, sinking air. Then this is HP. HP is known for atmospheric stability. Yes or no? Anticyclonic conditions? Yes. So second, because of this high pressure, this is atmospheric stability is found here. If anyone has difficulty in understanding what is atmospheric stability, let me know. Atmospheric stability, tell me for the cloud formation and for the rainfall to occur, what two conditions I mentioned? Warm and moist air, and second, its upliftment. And here, instead of upliftment, what is there? Sinking of air. Therefore, there is going to be cyclonic or anticyclonic condition. Anticyclonic condition, that is, anticyclonic conditions will prevail. Anticyclonic conditions will prevail, and therefore there will be no rainfall and no cloud. Because for the cloud formation to occur, what is required? There will be no rainfall, there will be no cloud, and the third thing, if there is no cloud, clear would be the sky, and therefore maximum amount of insolation will be able to penetrate. So maximum insolation due to clear sky. Okay, for your prelims. Second factor, this is latitude factor. Whatever the points are important for prelims, we have covered. So from equator to pole, temperature generally decreases, generally, except subtropics. Here you will see the maximum temperatures are recorded somewhere around 20 to 30 degree north. Exactly 4th of July, that was in Libya. Which hemisphere will record more temperature? Northern hemisphere. Why? Why? No. Because it is more land is there in the northern hemisphere. Okay? Because of the dominance of land, northern hemisphere will register maximum temperatures. Okay? Remember that. Next now, the second factor. Done with this? Again, I'm repeating for your prelims, every point has been covered. See here. Equator to pole, generally temperature will decrease. Why? Because insolation is decreasing. Except subtropic. Why? Because in subtropics, air is sinking, atmospheric stability, maximum amount of insolation is reaching. Okay. Why not maximum? Because clouded, most of insolation is reflected, rest of the insolation used in evaporation and basis of rainfall. Okay. Next now, second factor. Done na? Kya? That was upper atmosphere. We are talking about on the surface now. Near the atmosphere, near the surface, Earth's surface. वहाँ पे बात कर रहे हैं अभी. It's not upper atmosphere. ठीक है? Near the surface. Okay. Next now, second factor, altitude factor. Second, altitude factor. Now see here, I am putting 5-star on this one. Why? Because every year almost this question has been asked. Every year. Sometimes directly question, sometimes statements they have used from the same factor. Now see here, with altitude, what will happen? See here, with altitude, temperature should decrease or increase? Altitude wise, temperature decreases. Yes, na? temperature decreases, again you will use the word in general. In general, okay? There are exceptions. We will see what these exceptions are. So with altitude, temperature decreases. Okay. Now why it happens so? What is the rate generally? 6.5 degrees C per kilometer, known as normal lapse rate. Okay. Now tell me why. This why is something which is important, has been asked by UPSC n number of times. Okay. Tell me why. With altitude, what happens with altitude? क्यों? Okay. हाँ, yes. एक मिनट, हाँ. Yes, the first and the very important one is the atmosphere becomes warmer from where? From below. If I go with this logic, it means heat is being transported in the atmosphere from where? From the below. If I am going up, the heat transfer will become less efficient. Yes or no? Yes. So number one, that point is, you will remember number one. That is heat transfers in atmosphere. Heat transfers in atmosphere from where? From Earth's surface. Earth's surface. And at latitudes, at altitudes, at higher altitudes, this heat transfer becomes less efficient. This is on the board. I'm writing in short. This entire lines are written in your handout. If you have any confusion, just go through your handout. Okay? सर पूरा क्यों नहीं लिखते हो? फिर वहाँ क्यों लिखा है मैंने? ठीक है? On the board, if I'll write the full, then we need 10 plus more classes. Yes. Second point. So number one, we have learned because the atmosphere is becoming warmer from below. So see here, if it is the, see here, if this is the burner, gas burner. Now you want to make some tea. कहाँ रखोगे? बर्नर के ऊपर ना, या यहाँ रखोगे? If you want to make खिचड़ी or birbal, here. If you are want to, let's say you are interested in tea making, here. So if I am going up, what is happening with the heat? Burner को याद रखो. Just see the burner. If I am going up with altitude, because of the burner, which is nothing but Earth's surface, the heat is decreasing progressively with the altitude. That's it. Simple. कितना आसान है ना? Yes. Tell your mother also this logic. कि this is why Birbal was making khichdi. Second, tell me what will happen to the, with the altitude, what will happen to other factors? Batao. Density. So what will happen to the density? It will decrease. So why the density, if it is decreasing, temperature will decrease? Okay. Something else? If the density is decreasing with height, then what happens to temperature? Why it decreases? Yes, very good. If the density is decreasing means the atmospheric gases and the particles density is decreasing. Now tell me, who was able to absorb, reflect, scatter? It is the atmospheric, this gases and particles, na? Yes, na? If their density is decreasing, it means the capability of atmosphere to reflect, to absorb, to radiate, to scatter, everything will diminish. Yes? Now see here, second factor, but I just want to write this one. Water vapor factor. So what happens with the water vapor? Tell me. Water vapor is more confined, maximum I told you, where it will remain maximum 5 kilometer here. Maximum up to 5 kilometer. This is the water vapor. And now tell me, what is the property of the water vapor? It can absorb both incoming as well as outgoing radiation. So for example, it has absorbed the incoming and more it will absorb the outgoing. So what happens is it will trap the heat here. Yes or no? So heat will be trapped by the water vapor in this area. Do you know water vapor is mostly ignored when it comes to the climate change, but it is now established that the 50% of global warming is alone because of this water vapor. Okay, and our atmosphere is becoming warmer day by day. Warmer atmosphere can hold more moisture, more water vapor, and that is also how I will connect these points in the climatology. Okay, means in the upcoming part, jet stream and western disturbances. 7%, 7%. 1 degree C temperature, if it will rise, it will give additional 7% water vapor supply to the atmosphere. बात करेंगे आगे, ठीक है? See here now. If the water vapor is more confined here, if I am going up with altitude, what will happen to the water vapor concentration? If the water vapor is decreasing with altitude, then what will happen? Can I say trapped heat of the water vapor will also decrease? Yes or no? Yes. So water vapor remains confined in which area? Lower layers. In lower layers. And therefore, trapped heat by the water vapor will also remain in which layers? In the lower layers. Trapped heat remains in lower layers. This is the second factor. It has been asked alone many a times, water vapor and it's this property. Okay, second factor. The third factor is, see here now, the third factor that you will understand, see here now. If I say this is the Delhi and here it is the Shimla, this is Shimla. The Shimla's exact height from the sea level is 2200 meter. Okay, and if it comes to above sea level, it is above sea level. When it comes to Delhi, Delhi is only 202 or we can say roughly 200 meter above sea level. Okay, this is Delhi. And if you see their latitudes, okay, latitudes, if you will see, do you know both Delhi and Shimla are located near 30? पता है आपको ये बात? Both Delhi and Shimla. Delhi 29.74, Shimla 31 point something. More or less, can I say they are located near 30? Yes, na? But the temperature, annual temperature, the average temperature, 19 degrees C. The annual average temperature goes as high as 29 degrees C. Why this much of the gap is there in the temperature? Because of altitude. Yes. So what is happening in the Shimla? Please understand this with the help of this diagram. You will retain this. See here. In case of atmosphere, see here. In case of layers of the atmosphere, this is one layer, the second layer, third layer, fourth layer. This is the atmospheric layer. Now tell me where the density of the atmosphere is going to be highest. In this one, highest is the density, very high amount of water vapor and other particles are there. Density is now decreasing, further decreasing, further decreasing. Yes or no? Yes. Now see here, if the density of the atmosphere is decreasing, what will happen to its capacity to absorb the radiation? Will it decrease? Yes or no? Yes. Why? Because, sir, these are the molecules which are going to absorb. Yes or no? Yes. So it means, can I say with decreasing density, atmosphere will lose its capacity to absorb the heat? Yes or no? Yes. Number one. Number two, see here. At the same time, if you will see, if I ask you how many layers are exerting their pressure on Shimla, this is one, let's say this is one, two, three, four. Let's say four layers are there in the atmosphere, four layers of air. Only one layer is putting its weight on this Shimla. Okay? In case of Delhi, how many layers? The entire this layer are putting their weight. Because of the weight, can I say the compression would be there? Compression is also increasing the density as well. Yes or no? Now see here, please understand this factor very carefully. With altitude, the density of atmosphere is lesser, and also with altitude, pressure is also lesser. Because of less pressure, the less compression is there. Because of less compression, less heat is generated inside. समझ में आया? Maximum compression, maximum density, maximum pressure. Minimum compression, minimum density, and therefore minimum temperature. Getting? Yes or no? Yes. So third factor. What is the third factor? You can write this in three ways. What is the three ways? Number one, density of atmosphere decreases. Density of atmosphere decreases with altitude. With altitude. And therefore it loses capacity to absorb heat. So this is the density factor. Also, we can put in the another factors. What is the 4 and 5? 4 and 5. Pressure also decreases. Yes or no? Pressure decreases and compression effect. Air with altitude decreases. Because of all these 5 factors that you will remember, this is so important for your prelims. These 5 factors you will remember for your prelims. If any doubt, you can ask me. Okay, what are the factors? One, you are going away from the source of heat. Second, you are going away from the water vapor. Third, you are going away from the dense layer. Fourth, you are going away from what? The friction, compression, everything. And therefore, what is happening? The temperature is decreasing. समझ में आया? Yes or no? Source of heat, we are going away. Water vapor, we are going away. With denser layers, we are going away. With pressure, high pressure and compression, we are going away. That's it. This is going to be asked again and again. Okay? So this is important for you. Third now factor. Altitude we are done with. Third factor is distance. Third, distance from water body or sea or coast. Distance from the water body or the sea or the coast. Just give me a pen, please. Let me pass a signal. Yes. Thank you. So distance from the water body means, now see here, for example, some area which is coastal area I'm talking about. Let's say this is the coastal area. Okay, see here. This is the coastal area in which we have the water. See here, this is the water. Now tell me, which will become warmer first? Land or the, if it is the daytime, which will become warmer first? This is daytime. Land temperature will increase. Okay, so temperature, if it has increased, the warmer air, this is the warmer air now. What will happen? The warmer air will expand, it will become lighter, and where it will go? If it is lighter, it will go up. Yes or no? Yes. So warmer air will rise here, right? And if I ask you, when the air is rising, what are the conditions now here of pressure? Pressure will become low. See here, something is going away. Away means it is releasing pressure. If something is coming towards, it will increase the pressure. So this will cause the low pressure here. If I ask you the same area, ocean will have comparatively low temperature or high temperature? Comparatively low temperature. So comparatively low temperature means comparatively high pressure here. Yes. So what happens is, according to the law of the wind, from high to low, the wind is going to flow from the origin. We will call this sea breeze. Because it is starting from sea, so this is known as sea breeze. Now see here, if the temperature of the ocean, let's say it was 23 degrees C, and over land, let's say this was 33 degrees C. Now if the air is, the winds are coming from 23 degrees C area, they will be comparatively cooler. They will be mixed here. The temperature will come down. Yes or no? Yes, that is known as moderating effect. Moderating effect. And your temperature will come back again somewhat around 26, 27 degrees C in the daytime. Okay? So this is known as moderating effect. That is nothing but because of mixing of the air. This is the story of the daytime. Now what will happen in the night? Who will become, or which area will become cooler faster? Land, because of the radiation is faster. So this will become excessively cold at the time of night. Okay. Now, if it is cold, see here, in this area, instead of rising, this time the air will sink rather. It will create high pressure condition. The air is rather sinking here. Okay. The heavier and denser and cold air is sinking now. So because of that, high pressure is here. In this case, oceans will become slightly warmer at the time of evening. Why? Because they will slowly absorb the heat. So they are comparatively warmer. Therefore, the air will be rising now from these areas, and you will have low pressure rather in this area. समझ में आ रहा है? Yes or no? Yes, opposite is the picture now. Therefore, from high to low, what will happen now? The winds are going to flow. That is nothing but, this time it is known as land breeze. Now see here, because of again moderating effect, what is happening? This is connected cell. The warmer air after rising will come back here. Then this is the loop. And therefore, the moderation is continuously going on. Because of this, what you will remember for your prelims, number one, the point that you will remember that marine type of climatic conditions, marine type or coastal type of climatic conditions, are known for low range of temperature, both diurnal means 24 hours and annual as well. This is something that you will remember for your prelims. In every marine type or coastal type of climate, you will see low range of temperature, both in 20. What is range? Maximum minus minimum temperature of the day. Then it will be known as diurnal. Maximum of the year minus minimum of the year. So because temperature is moderated again and again, this is the chief characteristic feature of the coastal or the marine type of climatic conditions. Yes, why? If I ask you why it happens so, this will give you, the UPSC will ask you in this way. The coastal areas will receive, and then they also can put some name. Mumbai receives, Mumbai has comparatively low range of annual temperature than Delhi. Is it yes? Yes. The low range of temperature of Mumbai can be contributed to the moderating effect. Yes or no? Of the sea and the coast? Yes or no? Yes. The fishermen, third statement also no, the fishermen can take the advantage of this land and sea breeze. Yes, yes. Fourth statement, so no, the fishermen will enter into the ocean in the afternoon to take the advantage of the breeze. Afternoon. Afternoon mein they will enter or they will come back? They will come back. So please listen carefully. They will take the advantage in the early morning at 4. The earth will have the minimum temperature at around 4. Brahma Muhurat, right? In that time, what will happen? Which breeze will start? Land breeze or sea breeze? The minimum is the temperature, 4 a.m. Land breeze will start and the fishermen will take the advantage and they will go and enter inside the ocean. And by which time they should come back? If they want to take the advantage of this ocean breeze in this way, they will come back in the afternoon so that the tailwinds could be there for them. Samajh mein aaya? Yes or no? Yes. So please write down. The fishermen enter in ocean early morning. Fishermen enter in oceans early morning to take the advantage of which breeze? Land breeze. This is for your prelims. To take the advantage of land breeze. And they return by afternoon. They return back by afternoon with sea breeze. With sea breeze. With sea breeze. Next factor, fourth factor. Each factor is important. Okay, this factor is also important. Next factor now. The nature of land and ocean. Tell me which will become warmer first. Why? Because of less specific heat requirement. Less specific heat requirement. The first point I'm writing, the land heats and cools faster. Now, why it is so? They can ask you in this statement. Why it is so? Number one, because of less specific heat requirement. Number one. What is the specific heat requirement? For example, for the same amount of the volume, if the 1 degree C temperature is to be increased, the land will take less time, less energy compared to the water. Now, why it is so? See here. Number one, if you see this is the land. See here, land means it is solid, na? Solid means molecules are tightly placed, yes or no? If they are tightly placed, they will take less energy. Yes, na? In case of water, the molecules are away from each other. Therefore, they will take more energy to increase the temperature of 1 degree C. Yes or no? This is the main region. Now see here, the other region. This is the land, and here it is if the ocean. See here. See here. This is the ocean. In the ocean, up to how much of the depth sunlight can penetrate? It can penetrate up to 200 meter. Okay, up to 200 meter. And in case of land, hardly 3 feet. Hardly. This is 3 feet. Or maximum 1 meter, you can say. Okay, this is the maximum one. Now, because it is nothing but because the land is we can say the land is something from where the sunlight cannot pass, and therefore sunlight is concentrated on the upper layers. Because of that, the upper layer will show you quick change in the temperature. Whereas in the ocean, entire this 200 meter is handling the same amount of insolation. If 100 units here and 100 units here, where they will cause more heating? On the land. Why? Because only this thick land area is subjected to the insolation. Got this? Second, now see here. In case of the land, if the temperature has increased to 100 degrees C, let's say, okay, extreme, I'm assuming 100 degrees C. Now tell me what land will do. Kuch nahi, sir. They have to release this temperature. What are the options to release or to transfer this energy? For example, we have the options like conduction. We have the option like radiation. We have the option like convection. Yes, na? So these are the options. Yes. Now tell me, conduction is efficient or poor in case of land? Conduction से कितना ही transfer कर पाएंगे and कहाँ करेंगे? Land to land. Therefore, it is difficult for the land to lose this temperature. Conduction is not going to be the way. What about radiation? They are trying very hard. Because of the radiation, Earth is losing its heat. But still, the water has one more advantage. What is the advantage with the water? Water, when it heats up, it can recirculate from here to another areas. But is this option available with the land? Delhi, if it becomes warmer, can Delhi go to the Mumbai? No. So that option is convection. What is convection? See here, what are these methods? What is conduction? See here. Conduction means if this is the surface which is very hot, and if I touch this, what will happen then? The heat will be transferred in the form of shock. Yes, na? So heat transfer with touch, conduction. Heat transferred without touch, when the molecules themselves are leaving their place in order to transfer the temperature, convection. समझ में आया? If the molecules are not leaving, this bottle is not leaving anywhere, is still the transfer of temperature. This is conduction. The liquid will have this convection possibility, but land will not have this possibility of convection. Why? Because land cannot move. समझ में आया? So therefore, to transfer the temperature, redistribution of the temperature is possible in the water, but the same redistribution is not possible in case of land. Can I say the convection is possible in the ocean? In case of land, convection is not possible. Land की बात करो, air छोड़ो, air is different. ठीक है? Yes or no? Yes. So can I say in this way? See here, the another reason could be number one. See here, one we have seen this one. Second, see here, convection is not possible in case of solids. Yes or no? Because of that, we can also say the another factor, redistribution of heat. Distribution of heat is less efficient in land than water. Yes or no? Yes. Yes. Then tell me, land or the ocean, which area is going to be clouded more? Cloud कहाँ पे ज़्यादा होंगे? Over ocean. If the clouds are there over the ocean, what will happen then about insolation? Tell me. Less insolation will reach, and therefore they will become less warmer. So fourth reason, compared to the ocean, they are less clouded. And because of compared to the ocean, we are saying less clouded, and hence what will happen? More insolation they will experience. Yes. The another problem, see here, most of the insolation that was reflected, rest of that, if it is allowed, this is also used in what? Evaporation process. Yes or no? Evaporation. Is it possible on the land? Answer is no. So water bodies are losing their temperature continuously by the process of what? Evaporation also. It is also not possible in case of land. So these all are the factors. Evaporation is not possible. The insolation is not used in evaporation also. Again, I'm telling you the reason. See here, one by one. See here. Number one, less specific heat requirement. Why? Because tightly spaced molecules will take very less energy. Second, it is because solid. Okay? Solid, tightly. Second, because it is opaque, not transparent, the heat is limited to upper 3 feet. So the heat is concentrated in the upper layer. Temperature will increase faster. Third, the land cannot move. कभी देखा है rock का temperature बढ़ गया, rock is going up? नहीं ना? But air will go. Solid and liquid and gases, they will go up in order to transfer the temperature, but land will not, solids will not. Yes, so that is also the problem. Convection is not possible in the solid. Then redistribution of heat is not efficient here. Water will recirculate continuously. This is not option here. Then less clouded are the land areas than the oceans, therefore more insolation will reach, and the rest is evaporation is also not possible in case of land compared to the oceans. That is the factor number 4, I think. Done? 4. Next is simple nature of the ground surface. Tell me, if the ground surface is darker, what will happen? Surface, if it is darker, it will absorb more heat and therefore temperature will increase. Therefore, in the summers, which color of clothes you must wear? Yes, light color, and avoid black color clothes because they will absorb more, right? So this is albedo factor, nature of the surface. What is the next factor? Slope. Now, yes, this is important. See here, slope. Slope of the region. This is important. Please understand this carefully. Slope of the region. See here. If I ask you, this is the, let's say, Himalaya here. Now, this is southern slope, this is northern slope. Tell me which slope of Himalaya, sir, already this is leaked. Answer already you discussed. याद नहीं है ना? फिर तो नहीं हुआ leak. Which slope is more sunnier of Himalaya? Why it is so? Yes, tell me. Why? Because maximum sun can come where? Maximum sun northward can come up to 23 and north, this one. Yes, na? So can I say the southern slope will receive most of the insolation when the sun is here? Opposite side, northern slope will not receive that heat energy. Yes or no? Yes. So please see here, they will give you in this form. They will give you in the northern hemisphere. ध्यान से सुनना. In the northern hemisphere, the mountains which are running west to east, and if they are located beyond the tropics of, what is this, Cancer or Capricorn? Cancer. They receive more sunlight in their southern slopes. Yes or no? Yes. So the condition is the mountain should be away, let's say, in the northern hemisphere, number one. And if the same question, if I ask you for the southern hemisphere, tell me, can I ask you then in this way? See here, if it is southern hemisphere, see here. Southern hemisphere, if it is, see here, the southern hemisphere. This is southern hemisphere. When the sunlight will be maximum here, let's say this is 23.5. Now tell me, the same Himalaya, if I am talking about in the southern Himalaya, southern hemisphere. This is the maximum march of the sun. Now tell me which slope will receive more sunlight? Northern slope. समझ में आया? So that is the point. They can reframe this in any way. The another point. Now tell me. This is, see here. If any mountain which is running west to east, and if it is located in the northern hemisphere, their sunnier slopes will be southern slopes. समझ में आया? Example, Himalaya. Alps also. Okay? Alps also. Now see here. Second. See here. The second slope wise, I'm giving you the example. Tell me, if this is the Western Ghat, tell me in which side of the Western Ghat the temperature is going to be more? Eastern side or Western side? Where? Yes, tell me. This is Western side of Western Ghat, the Eastern side of the Western Ghat. Yes? Which? Sun rises in the east. Yes. Tell me. Sun rises here, okay, then which one? This one, okay. Anyone? Where the temperature will be more? Eastern side. Why? West has, okay, moderating effect, okay, fine. And we are talking about slope only. हाँ ठीक है, बताइए. Yes. The another leeward, yes, rain shadow region, yes or no? Yes. Now see here, if you go by this two logics, this is the Western Ghat. See here, this is the Western Ghat. Number one, this is windward side. Yes, windward side means here the mountain will have the rainfall, good amount of rainfall. Second, also this side we have the moderating effect of the land and sea breeze. Okay, sea breeze and land breeze. Because of this two reason, temperature will be less in this area. What about this side? When the air is going down, if the air goes up, temperature will lowers down. If the air will come down, temperature will increase. So this air will become warmer, and also it will not cause rainfall here. This is known as rain shadow areas. So rain shadow is the region. Therefore, what is the area here? Vidarbha, Maharashtra. This is nothing but arid and semi-arid region. So slope of the area will also determine what would be the temperature. Yes? Temperature would be there. Yes. The rain shadow side it is. Second, this side also the temperature is decreased because of two factor. The coastal factor as well as it is the rain bearing side. The rain will happen here. The windward side it is. Okay. That is how the slope will matter. Now tell me, for example, one practical देखते हैं कितना समझे आप लोग. Tell me, you are living in Delhi. The room, if you are going for, you are looking for a room on rent. Let's say this is the room, and in Delhi you are. If I give you the room, you are in the summer. I'm giving you this room. The entire this is made up of glass. Will you prefer this room in the Delhi summers, or you will prefer this room? Glass is this side. कौन सा रूम प्रेफर करोगे? कोई सा मिल जाए सर. Which room you will prefer? Conditions are the glass is here. अब ये भी मैं बताऊं डायरेक्शन भी. This is which direction? Southern side. This is northern side. फिर तो सवाल ही खत्म हो गया. Tell me in Delhi, if you want to take the room, the hot summer consider, where you will take the room? Which facing? North facing? The north facing means the northern side, the glass window entirely, or southern side? Sir, पहले समझाओ हमको समझ. अरे यार. The application, see here. This is Delhi. Where Delhi is? Here. Where the sun can come maximum in the summer? Here. Sun can come maximum here, na? If you are preferring this room, maximum sunlight will enter. Yes or no? Yes. If you are preferring the other side here, no sunlight, not much sunlight will come. Yes or no? Yes. Practical application. Yes. बता दोगे अपने पापा को कौन सा लेना है? Yes. And now tell me with the same logic. समझ में आया? हाँ. See here. This is Himalayas. Yes. Which slope of Himalaya was receiving more sunlight? Southern slope. It means if I am going beyond this 23, southern slopes will be more sunnier. ठीक है? Southern side से ज़्यादा light आएगी. If you have southern side window here, the room has this window here. This side आपका अगर glass है, so what will happen? Maximum sunlight will enter. Yes or no? Hello? The sun can come maximum here, ना? The sun can come maximum vertically overhead here. समझ में आया अभी? Therefore, the south facing window, छोड़ दो ये नहीं पूछेगा. If you are in Bangalore, the summer it is, which facing room you will take? South में glass हो या north में हो? Why? Because if you will take north window, the sunlight will come maximum from where? The sun is here, from the north. Can you understand that? This kind of questions can also be framed from the same topic. Okay? R is living in Delhi. The month is summer. The room is this way. ठीक है? CSET में आते हैं छोड़ो. Next. The factor, how many we are done with? 7th factor. Tell me what is the name? Huh? Prevailing winds. Okay. Prevailing winds. Now tell me, winds, what is the role of the winds? Can I say redistribution of heat energy? Yes or no? redistribution of heat. Now see here, from equator, this is equator. If the winds are going to pole side, what they will be? They will be transporting heat, yes or no? Yes. So if the winds are going from equator to pole, they will increase the temperature of this area or decrease the temperature. The winds are coming from warm areas. If they are going from warmer area from equator to pole, what will happen to the pole side? Temperature will increase. So this is nothing but the temperature is going to increase. If the same air or the wind is coming from the polar area towards the equator, then what will happen? Temperature will decrease. Number one. So what is the role of the wind? If they are coming from cooler area, they will reduce the temperature in another region. If they are coming from the warm area, they will increase the temperature of other region. Yes or no? Yes. Now see the practical example. See here. Let's say this is the Europe. Okay, page number 106. Open the 106. Page number 106, oceanic currents. See here now, 106, and for new edition 110 it would be. Miller? For new edition 110 it would be. For third, fourth edition 106. Miller? ओशनिक करंट्स, हाँ दिस इज 107 पे आपके न्यू एडिशन है ना ये ओल्ड है हाँ 106 107 107 ओशनिक करंट्स कैन यू फाइंड दैट फॉर न्यू एडिशन इट वुड बी 111 110 ना हाँ ठीक है 110 now see here the current what current it is reaching here in the Europe just see here what is this North Atlantic drift can you see this North Atlantic drift yes the North Atlantic drift means it is warmer red it is in color देखो it is warmer. Now tell me, if the warmer water is there and the wind is coming over this warmer current, that is westerly, can I say it will also be warmer? Therefore, what happens is, even in the winters, this Western Europe, Northwestern Europe, will not experience freezing temperature. Rest of the area of the Europe will be under severe winters. This coastal part will be experiencing moderate temperature because of both reasons. Number one, the warm current, and second, because of warm westerlies. That is the role of the wind. Can you understand that? Yes. Now see here, with the same logic, tell me, if I ask you, this is Africa, see here, the same area, see here, Africa. In this Africa, see here, in the Africa, this is equator. What winds are here? The winds are trade winds. Okay, these are trade winds. Trade winds, if they are flowing here, the warm water of equator, it will be dragged in this direction, yes or no? Dragged in this direction, yes or no? Yes. Therefore, warm water will be pulled in this direction. Now, therefore, in the African part, equatorial part, lower latitude parts, eastern margin of the continent will see rise of temperature. समझ में आया? That is the role of winds. So simple, the winds, when they will come from warmer area, they will increase the temperature. When they will come from the colder area, they will decrease the temperature. Example, Lu. What is Lu? Local wind. So when the Lu is there, it is coming from the hot areas. What happens? Lu is something which is very warm, yes or no? Yes. So that is the role of the wind. Next factor must be the role of currents. The same factor, see here, same factor. North Atlantic drift is causing what? If the warm currents are there, they will increase the temperature. If the cold currents are there, they will decrease the temperature. Now, please locate at the same page the current wala page, 107 and 110. Now, please locate North America and just see North America has two Gulf. One is Gulf of Mexico, second is Gulf of California. Can you see the currents are different in nature? Gulf of Mexico has warm, whereas Californian current is cold. Tell me, the Gulf of Mexico will go through more temperature or California? Mexico, because of presence of warm current, and because of the presence of cold current, Californian area will have less temperature. That's it, simple. The last factor we are left with, role of cloud. That is very important. Please understand carefully the last factor. The last factor, and this is so important, it was asked as a direct question in 2023. 2023 nahi yaar. Year is different. This was the direct question. Okay? Year I forgot. But in last 5 years, it was asked. Okay? The last factor. Now see here, the first thing, the role of cloud is something which is very complex, right? Why it is very complex? Because it depends on many factors. What are these many factors? Number one, altitude of the cloud. See here, see here. It depends on many factors. For example, altitude of the cloud. Second, for example, the expansion of the cloud itself. Third, whether it is made up of water vapor more or the ice crystals more. Yes, then these are the factors, and then some other, that is atmospheric conditions nearby, climatic conditions nearby. Their role is something which is highly complex, therefore, to understand. Okay? Now see here, anyhow, it is the NASA. On their site, it is mentioned that this is overall role that we have so far understood. So this overall role you are just seeing from the direct site of the NASA. Now see here, the same statement were taken from the UPSC directly. And this is something that you are supposed to remember. The two type of clouds I'm making here, this is the surface, the thin clouds here, and the thick clouds. The thick cloud. This is the thin cloud, upper clouds. So I'm writing here thin and high clouds, and thick and low clouds. Okay. What is the overall role that they are playing? See here. See here. The first cloud, it is playing major role in reflecting this signals back, sorry, radiations back. Major role. However, some of the radiation will also reach. Okay? This is the major role. More role is played in cooling or warming. Tell me now. The more role is played in cooling of the Earth's atmosphere. Okay? So this is the role of this cloud. Now see here, most of the insolation is allowed to pass here, most of the insolation, and least of the insolation is reflected. So what is the role here? Overall role is warming. And the another problem with this type of cloud is when the Earth loses its heat through the long wave radiation, this is also trapped by this cloud and reflected back towards the atmosphere. Therefore, this cloud, what is the cloud? The cloud is thin and high cloud. They are responsible for overall warming of the Earth. Whereas the thick and low clouds are responsible for cooling of the cloud. Tell me which clouds are more dominating? Which clouds will be more dominating? Lower and thick? Yes, na? Yes. Therefore, yes, yes. Please say yes. Okay, yes. The lower clouds will be dominating, and therefore overall role, if I average what they are doing, if I average that, who is dominating? These clouds are dominating. Therefore, overall role of the cloud is cooling. This is important. That is the last factor. Now we are ending our class here. We'll start from on Monday now. Okay. Or shall we extend more? I just wanted to hear that sound. हाँ, I'm not leaving. I will stay here. बताइए.